One of the things you will have to learn for organic chemistry is, of course, how to write organic structures. When you're in Gen Chem, your writing of structures is very different. And when you get to organic, it becomes really different because now you're dealing with carbon structures and all covalent compounds. Okay, so things become a little bit different. So let's get started. So there are different kinds of formulas that you have. You've learned about the molecular formula, and the molecular formula is where you have just the number of atoms given to you in a certain order. Okay, and usually for organic chemistry, we will start with carbon first, and then hydrogen, and then any other heteroatom, which is anything other than carbon or hydrogen. So that's the molecular formula. Empirical formula, if you remember from your Gen Chem, was where you have the smallest ratio of atoms, okay, in anything. So right now, the empirical formula I have given you is the smallest ratio for the molecular formula given right here. So just divide it by the common denominator, which is 2, and so you get CH2O. So this is molecular formula and empirical formula, which you already know from Gen Chem. Now, in organic, you're going to learn other kinds of formulas, and these three that are given on the top here for you, these are new things for you. So first one is the full structural formula. This structural formula, or the expanded structure, this is where you see all the connections of the atoms. Okay, so how many bonds there are, and how the atoms are connected to each other. That's kind of how you write the full expanded structure for any organic compound. So it's very clear. You can see all the bonding. Then there is the line formula. The line formula is all lines because we have carbons. We're dealing with carbons all the time, so we don't write carbons out. So for each point, we will say this is a carbon and then this is a carbon, and then you can see that we don't write hydrogens out. So the first carbon, which is supposed to have 3 hydrogens, does not have any hydrogens written on the first carbon that I'm pointing to. And that's because hydrogens are also taken for granted that you are going to have hydrogen. So they're kind of invisible, but they're there. The only hydrogens we write are the ones that are connected to the heteroatom, like oxygen, nitrogen, sulfur, all of those. Okay, so they will have the hydrogen. You'll have to show the hydrogen for that, but not for carbon. Okay. There'll be one carbon that will show, but that's a different thing. That has to do with functional groups. Okay, and then finally, it's the condensed formula. And in the condensed formula, what you do is you write the formula according to how the structure is written out. So for example, here on the first carbon, here you have a carbon. That carbon has 3 hydrogens attached to it. How do I know there are 3 hydrogens? Because there is only one bond here on carbon. So the other 3 must be hydrogen. Then you have the carbon, which is this carbon that I'm pointing to. And then you have 2 oxygens connected to that, and then a hydrogen. So it's all written out as you would find in a structure. So literally you can take a condensed structure and draw a structure out of it. Whether you want to draw a structural formula or you want to draw a line formula, you can draw that out. You cannot draw a condensed structure using a molecular formula, okay? Because the molecular formula is not really telling you how things are connected. It's just telling you how many atoms there are. So that's all it tells you, okay? So it's kind of incomplete, okay, in a way. So now we're going to learn a little bit more about all these things. Okay, so here are some structures that we will deal with. So condensed structure is what we start with first. So structures can be given to you in any which way. You can be given a condensed structure, asked to draw in a line structure, could be given a line structure to give an expanded structure or condensed structure. So everything is kind of interconvertible one way or another. So first of all, what is a condensed structure? A condensed structure is one in which you will not see any bonds at all. Okay, now fully condensed structure is where you do not see any bonds at all. And partially condensed is where you see some bonds sometimes, and it depends on what kind of structure you are trying to draw. Okay, Now, generally, when I give you structures, I prefer absolutely no bonds, okay, which means that I'm asking you to draw me a fully condensed structure in which you're not showing any bonds, okay? So whether it's some branching going on or whether it's a double bond, you are not supposed to show any of those, okay? So just draw just the atoms out. So let's look at this structure here where you have 3 carbons in a chain, and then you have all these hydrogens. Now remember, when you draw a condensed structure, you're supposed to show all the atoms in the correct order, okay, that they're connected. So the first carbon here has 3 hydrogens. So the way you would draw the condensed structure for this is you have this carbon with the 3 hydrogens. Then you have a carbon which has a hydrogen, so carbon with a hydrogen. And then the carbon in the center still has one OH connected to it. So then you write the OH. And then you have a third carbon with 3 hydrogens. So you have a third carbon with 3 hydrogens. Okay, so this is the normal way of writing it. Now, what happens in organic is there is generally more than one way that you can write things. Okay, so let me tell you all the different ways you can do, and all of them are correct. Okay, all of them are correct. The partial one, not for me. Okay, so this top one here, this is the partially condensed structure, and you will not be writing this for me at all. Okay, so I just want to show this to you, but I also want to show you what you should not be doing. So let's look at the different ways you can actually draw this condensed structure. Now, if you draw this one, it's completely fine because it gives you the exact placement of all the atoms. Now, if you want in the beginning, okay, if you want to do this, and even later on if you want to do this, you can put the OH in the bracket, because technically speaking, this OH, these 2 atoms are together. So if you feel like you're getting lost in the hydrogens and the oxygens and all, and you will not be able to keep a track of things, no problem. You can draw brackets around the OH. Okay, so that tells you that this whole group, okay, right here, this is connected to this carbon. All right, so that is one way of keeping track of things. All right, is putting them in brackets, and we'll do some more examples later to see how you can do that. The second structure that is given to you over here, this is also correct. Okay, and again, this one takes a little time. The first one, I know this one you understand. This is pretty normal. Okay, this one is the normal kind of structure. The second structure here, this one that I just did, I think you will understand that too. The last one is a little bit harder to understand. So let me show you how you view this, because this one is saying that you have CH3, but you have 2 of those connected to the CH. So let me show you how this can be drawn out. So here you have the CH3s, the 2 CH3s, okay, so CH3, CH, 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 and then CHOH, okay. So now if you just turn this structure around, okay, 90 degrees, if you turn that around 90 degrees, the 2 CH3s now are on the same side. And so once you see that, you're like, oh, okay, so I can do this. I can put the 2 CH3s in a bracket because I have 2 of the same things, and then I can have the CHOH. Okay, so this is a little bit harder to visualize, but it's not a wrong structure. So once you start getting comfortable with things, then you can do this as well. Now, regarding of what I will give you, I can give you any of these condensed structures and ask you to write me an expanded structure or a line structure. Okay, so you should be ready for everything. So that's why we learn everything. Okay, the expanded shell, okay, or excuse me, the expanded formula. So how do we write the expanded formulas? You show every single hydrogen, okay, in there, how things are connected. Now, the one thing that is important for us to know in expanded formulas is that the connectivity is the most important, okay, and whether you draw hydrogen going up or down, or like, for example, in this case, you have the OH is going down, but in this case, the OH is going up. All of these things don't matter, okay? Why don't they matter? Is because you're dealing with all the single bonds. So if you have single bonds, you actually have complete rotation, okay? And that rotation allows you to rotate the bonds any which way you want. So at one point, maybe the OH is up, and another point OH is down. That doesn't matter. What matters that it is connected to one carbon or the carbon that is terminal. Okay, so that's what's important over here. What is the condensed structure for this? Let me write that also so you can see what it is like. So you have 3 carbons and then an OH. Okay, so you have 3 carbons, CH3, CH2, CH2, and then OH. So if you have something like this, I want to make sure that my 3 carbons are connected like this in a straight chain, and this is a straight chain. We consider this to be a straight chain. If you don't like the angles, you don't have to do this. You can draw it like this as a straight chain. Okay, so which means you can write it like this, CCC, and that's fine too. Okay, either way is fine with me, provided that you get all your hydrogens in the right positions or in the right connectivity. Okay, and then the last is of course the OH, so there we go. Okay, if you write the OH, it's fine. If you want to write O-H, that's also okay. Now if you exchange this OH with the H, that's also okay, because remember, these are all single bonds, they can rotate freely. Okay, the most important thing is that the 3 carbons are connected in a straight chain. Okay, so that's expanded formula. The line formulas are probably going to be our, I don't know, the hardest thing in the beginning, because you don't see any carbons, you don't see any hydrogens. So sometimes it's easy, sometimes it's hard. I don't know how it's going to be for you, but in any case, this is how organic chemists live their life, so you have to get used to it. Okay, so here we have an example of everything, which is the condensed structure, the expanded structure, and then not so much of expanded structure, but a little bit, and then the line structure. Okay, in the line structure, the rule is that you don't draw any carbon, you don't draw any hydrogen, unless that hydrogen is connected to a heteroatom. A heteroatom is again anything that is other than carbon or hydrogen. You have to show all the heteroatoms, so any chlorine, oxygen, nitrogen, sulfur, you have to show all of those. Okay, only carbon and hydrogens are allowed to be invisible. All right, so here you have a structure given to you. So what you do first is you identify all your carbons in a straight chain. Okay, so you're like, okay, I have a carbon here, I have a carbon here, I have a carbon here, and I have a carbon here. So I have 4 carbons going on. So then what you will do is you will draw this kind of a line. Okay, now this angle right here should be about 120 or 109. Okay, because 120 and 109 kind of look similar when they're drawn in a 2D manner. And that is in keeping with the bond angles for an sp3 carbon. Okay, sp3s are tetrahedrals, the bond angle is 109. Okay, so you want to make sure that you keep the structure nice and symmetrical and to the proper bond angle. Okay, so that's 4 carbons right there. And then on the second carbon, you have a hydrogen, and then you also have a Cl. So on the second carbon, you have a hydrogen, which you are not going to show, and then you have a Cl. Okay, also. There is no other heteroatom, so it's just CH2, CH3. Now, if you look at this structure, you can see it's drawn slightly different in the sense that the first carbon is coming down, the first 2 carbons that's coming down, mine is going up, and that is completely fine. It's up to you how you want to draw it. The most important thing is your chlorine should be on the second, okay, atom. Now on the second carbon, okay, now this is exactly the same as this, okay. Either way, okay, the chlorine should be on the second carbon. That's the most important thing here. So the connectivity still matters, the order still matters. Okay, so that is a line structure. Now you can see that we don't have any carbons showing, we don't have any hydrogens showing. Okay, you have to understand yourself that you actually are going to have 3 hydrogens on this carbon, you're going to have 1 hydrogen on this carbon, 2 hydrogens on this carbon, and then 3 hydrogens on this. So this is something that is understood. So in one of the exercises you have to do for me is you also have to write the molecular formula for compounds. And when you write those, then you have to be able to count all these hydrogens, okay, in there. Okay, so the second structure will become a little bit easier for you to understand now. So you have 1 carbon, 2 carbon. Now this is brackets over here. This carbon is in the bracket. It means this group is attached to this carbon. Even if it was not, in brackets, it would still be attached to that carbon, because the CH3, you cannot have a CH3 in the middle of the chain somewhere. You will violate the octet rule, okay, if you have a CH3 in the middle. So you can't have a CH3 in the middle. So the middle means that it is a branch somewhere, okay? So then 3 and then 4 carbon chain, okay? So it means that on the second carbon, you will have a CH3 coming out of it. So this carbon and this carbon right here, this is a CH3, this is a CH3. Why? Because this is a carbon with 3 hydrogens. Okay, so that is how it's going on over here. Let me erase all this so it doesn't look too messy for you. But in any case, that's the line structure. We don't have any heteroatom to show here, so we will not write anything. So it's just lines and lines and lines. Okay, and this is so much easier for us in organic chemistry because you don't have to draw all the carbons and hydrogens out. It's just too much work. Okay, let's look at the last one example here. So CH3, so you have 2 CH3s, okay, because it tells us that there are 2 of them connected to a nitrogen and then a CH2 and a CH3. Okay, so the first thing that I would do if I was drawing this is I would draw the nitrogen. So I would draw the nitrogen first, okay, and then I'll see what is connected to it. So I have 2 CH3, so then you have the lines coming out, and the lines that we have are of course here and here, and then there is a CH2, CH3, so CH2 and then the CH3. So that means 2 carbons, okay, on that side. So that means the 1 and the 2. You have 1 and 2, so 1 and 2 right there. Okay, so that's the line formula. So let's practice some more in the next slide. So for cyclic compounds, I guess we'll practice in the next one. So for cyclic compounds, you still have the carbons and the hydrogens. Again, if you have a heteroatom, you have to show that in the ring, but otherwise you just draw them as triangles and squares and pentagons, depending on how many carbons you have in there. Okay, and so writing the condensed structure for a cyclic compound is a little bit harder because how do you show it's a ring? Okay, and I'll show you a trick for that, but again, we don't use this so much because it's just easier to draw the ring out. Okay, so for example, for this structure right here, if you wanted to show this in a ring form, you will say, okay, you got 4 carbons and all 4 carbons are CH2, so you have this. I mean, it's kind of hard to draw that on a computer, so you can write it out, but you can't really draw it on a computer. So it's much easier to just, say the name or draw the structure out. Okay. All right. But that is how you would do the line structure or the expanded structure for a cyclic compound. Okay. In an expanded structure, you'll draw all the hydrogens out. This is not really a true expanded structure. And then again, if you have multiple bonds, not again, but if you have multiple bonds, okay, in any compound, then in those multiple bonds, you have to show that also. Okay, so in this case, there is a double bond. How do you know there is a double bond or a triple bond? Well, you have to look for the number of hydrogens. So if hydrogens are missing, it means that you probably have a double bond. Okay, so make sure you keep account of your hydrogens because this is how we write stuff out. Okay, so for example, in this case, the condensed structure for this one, okay, the condensed structure that I would write for this is that I have a CH3 connected to a carbon, and then I have another CH3, and this carbon right here, okay, this carbon does not actually have a hydrogen. Okay, so let me go ahead and erase that because this carbon already has 4 bonds, right? So 1, 2, 3, 4. It has 4 bonds. It doesn't have any hydrogens. Now this carbon right here is connected to this one. So that carbon now has 1 hydrogen because that carbon has 3 bonds to it, and then there is a CH2 and then there is a CH3. So that is actually the condensed structure, okay, for this. Now you can rewrite this a little bit better, and we will go ahead and use our brackets. So CH3 because you have this CH3 here and this CH3 over here, so you can use that, okay, as your CH3 and then you have the C and then CH, CH2, CH3. Okay, so that is something you can do. Now, please remember this CH3 is not the same as this CH3. Okay, so don't pile them together as three CH3s. You have to write the condensed structure as complete as possible. Okay, so in any case, here is another example, okay, that you can look at. So in the line structure, you will draw the double bond, and then you'll draw the O, and then you also draw the hydrogen here. Remember, I said that you have to show the hydrogen that is connected to the heteroatom. Okay, so that is how you draw the line structure for this. Okay, so here is an example for us to do. So they have a molecular formula C6H12. We're given the condensed structure. So let's go ahead and write the expanded structure for this. Expanded structure is a little bit of a pain in the behind because you have to write each carbon and hydrogen out. But here's what we're going to do. We are going to go ahead and count all the carbons first. Okay, so that's what we are going to do. So 1, 2, 3, 4, 5. So if you noticed, I didn't count the one in the bracket. Okay, and I'm not going to do that because I know that this carbon is going to be connected to this carbon right here. So I am not going to count that. Okay, so now let's go ahead and write the expanded structure for this. And so 5 carbons, right? So I'll go ahead and draw out my 5 carbons first. And then the first carbon has 3 hydrogens. My writing is not the best. The next carbon is going to have the 1 hydrogen and then this whole group connected to it. So that is this right here. And then that's the CH3 taken care of. Now I'm on the 3rd carbon. The 3rd carbon has hydrogen and hydrogen. Then 4th one also has hydrogen, hydrogen, and then the 3 hydrogens on the last one. Okay, so pretty painful to draw, but we're there. The line structure, I have 5 carbons as I labeled before. So with the 5 carbons, I'm going to do this. Now you want to be careful that when you draw your line structure, you always count your carbon as 1, 2, 3, 4, 5, not 1, 2, 3, 4, 5, because that will give you one more carbon. Okay, so be careful when you're counting your carbons. So in the line structure, I drew the 5 carbons out. On the second carbon, I know that I have a CH3. Okay, so that's kind of how this example works out. So here is a line structure given to us. Now we have to write the molecular formula, condensed structure, and the expanded structure. So we can start wherever we want. Let me go ahead and start with the condensed structure first. Okay, so nobody says that I have to do it in the order that I'm asked. Okay, so the first condensed structure. Now I can do it in 2 or 3 different ways, and I want to do it in all different ways so you can see how it is done. Okay, so I can take the chain first. Here is, hold on, let me do this. So here is my chain, okay, that I have. And so I'm going to take that chain. So I have 4 carbons in there. So which means I have a CH3. And then this carbon right here, it doesn't have any hydrogens, right? It has 2 CH3s on it though. So I will go ahead and write CH3 2. And then I have a CH2 and a CH3. I can write another way also because on this carbon I have 3 CH3s. So I can say CH3, 3 carbon, and then CH2, CH3. I can do that. Okay. How else can I write this? Well, this CH3s, I can move it after this carbon also. That will also be correct. So there is some flexibility, okay, on how you're writing all of these structures. Don't take too much liberty, but there is some flexibility. If you wanted to write this structure as CH3, 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 CH2, CH3, this will also be fine. It's just that, you know, there's so much writing to do when you have to do CH3, CH3. Okay, so as you're getting comfortable, okay, do as you're getting comfortable. Now for the expanded structure is a little bit painful, but there are 4 carbons in the chain. So here are my 4 carbons. In the first carbon, I have carbon, no, this is not that one. Wrong. This carbon. So carbon, carbon. On the second one, I have hydrogens, hydrogens, hydrogen. Sorry about my handwriting. It's always like this. Okay, and then 3 hydrogens here. I know you'll do a much better job than what I'm doing right now on my computer screen. Okay, so that is my expanded structure. Just make sure everything is connected the way it's supposed to be. Now for the molecular formula. Okay, so for the molecular formula, I can take any of these structures and just count the carbons and the hydrogens. Okay, so I prefer using the expanded structure for this. I mean, you can use condensed structure also. Okay, so I have 6 carbons because 4 in a chain, 2 branching, so it means I have C6. And then all the others are going to be hydrogens over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, and 3, 14. That's it. I don't have any heteroatoms or anything else to write, so that is it for me for molecular formula. Okay, so it takes a little time to do all these, but you got to take the time, okay, to do it. So from this PowerPoint, hopefully you have learned all the different ways of writing a structure, whether it's line, expanded, or condensed structure, figure out the molecular formula from there, and be able to interchange, okay, from all of these things.